Okay. All right, guys. So rainbow. That's what we're drawing every time. So guys, I want to try this a little differently this year. We did these 3 scenarios with your Twizzlers, so I kind of just want to start with the problems so you can see how to use them. You don't need that. I know I'm skipping one. So let's try this first problem together and see what happens. We'll see how this goes for you. Clearly not drawn to scale since it says A is 120 degrees. That does not look like a 120 degree angle. Maybe no. Something.
Yes.
I know. This is quite the thermos placement. It's a cheesy math teacher mug, yes. Yes, that's perfect. To the other side. I don't get many apples. No. Not very useful. I'm gonna get like a bushel of apples. Yeah, I don't like those.
There's so many kinds of red apples. No, but the red teacher apple is bright red.
All right, guys, everybody have the triangle drawn. Okay, so when we look at this, first you guys see that it was put in the rainbow spot here. Our angle we know is down here, then side, side. Everybody gets that drawing? Okay. Our tree is the 36, the rope or the Twizzlers the 45. Yes, we're okay with that? All right. So first with this, determine if there's 0, 1, or 2 triangles formed. With the ambiguous case, when this angle right here that you're given is obtuse, right from the start, you don't actually have to do all the work of finding all of the triangles. You're just going to solve the one that's given, and either that exists or there's nothing. So let's try to solve this like you were solving last class with the law of sines. What do you want to set up as your law of sines proportion here? Okay. Equals. Well, what's the other side we know? 36, and that's across from B, right? So let's do sine of B over 36. Well, then you would have 2 variables because then you'd have sine of C over, like, this is little c. And you'd have too many variables. You can only have 1 variable at a time when you're solving. Okay? All right, so same idea as before. We're trying to get the variable alone. You can cross multiply, or you could just multiply by 36 to get rid of that. Okay, cancel that. Let me grab a calculator. So you need to key into your calculator 36 times the sine of 120 over 45. That is not your answer. That's what it's. Divide by 45. Are you guys, ooh, let's see. Yes, I'm in the right mode. Are you getting like 0.692820? Yes? Okay. That is what sine of B equals. What do I need to do if I'm looking for that variable that's the angle? Inverse. So you are going to do inverse sine of your answer. Do you guys know how to do the answer key on your calculator? It's the little negative sign right above it in blue. So you're going to do second sine, second answer, and then push enter. And we'll just go to the nearest degree for this. Are you getting 44? Okay. Okay. Yeah. On the bottom right. Okay. You see it? Okay. So you can your calculator. It's 44. All right, guys. We're gonna have to use the answer you got here, the 43.85377. Like, we're gonna have to use that again. So, what I need you to do is store that. What do you want to store it as? How about B, since it's B? I would do that so you don't lose track. So store that as B. Okay? Don't know how to store? Okay. Yeah, we did that the first day, so. Okay, so this key right here, store. And then I'm just going so now, like, if I typed in B, it's not as, it's very helpful.
Oh, I didn't have
Help? It's a face that definitely helps. Okay. So store. All right, now to find C, we know that our triangle should have 180 degrees, right? So I want you to do 180 minus 120 and then minus B. Are you getting 16.14, 16, okay? Rounded, clearly that's just going to be 16 degrees, but I would like you to store that as C. So store alpha C. Yes. Hmm? You gonna make it, Bobby? Okay.
Wait, can you
To get what? Yeah, and did you store it as C? So guys, make sure you store it as C. So what is the only thing we are missing from our triangle here? The side C, right? Okay, so we have to go back to our law of sines. So I'm going to do sine of 120 over 45 equals sine of C, and I'm going to go ahead and put in C like that because I know I need to use the stored value of C from my calculator, and then we're looking for little c. Now you are back to just solving law of sines like you did on all of your other homework. So cross multiply, we would have C times sine of 120 equals 45 times sine of C. So to get C alone, divide by sine of 120. I'll wait for you guys to get there, then we'll talk about how to key that into your calculator. All right, so you are keying in 45 and then sine of C. You have this stored as C, right? Okay, so just put in your C and then divide it by sine of 120. And if we round to the nearest tenth for the side, what do we get? 14.4. Is that what you got yourself?
Yeah.
Okay. Anybody not getting there or having calculator issues at all, please speak up if you're stuck in any way. No. Because that's not bad, right?
Yeah.
Right, okay.
Oh.
Are we okay with this one? I'm going to show you. It's basically when the Twizzler's too short. So you just have to find the length of your Twizzler. All right, let's look at the next one. This. Yes, you have to put it, so like this one, things aren't labeled. You have to put it in the rainbow order. All right, guys, write this one down. We'll do this one together. What? We're done with that first one.
Okay.
There's one triangle. Is that what you're talking about? Yes. So there was one triangle. So all that was there is the triangle that you guys see. Okay? And you found the missing parts. You found the two angles and the other side. And so then you're done. Okay? So let's try this one. This is number 2 today. So jot it down. You're going to have to label your triangle. I will help you do that. I'll let you write the info down first. So guys, what's the angle we know? Oh, sorry. Yes, tell me if it's too fast. We have B. No, but I see some people writing still, so hold on. All right, B, the angle you know, that goes in the bottom left. Goes down here. That's 3. Okay, we need a rainbow, right? Okay, so the two sides you have left are side B and side C. Where should they go? Which one is the tree and which one is the rope, John? Yep. Yep, perfect. So this is your 248.6. And this is your... Because remember, if this is angle B, side B's got to be straight. Okay, yeah, exactly what. I like how you were like... No. Always waiting for the year that, like, the administration observes me while I'm teaching this. It hasn't happened yet. Keep waiting. All right, so guys, that means this has to be angle C down there, right? Since side C was the tree. And angle A has to be up here. If you guys get that setup and are consistent with that setup, that is half the battle of doing these problems. Like, it really is. Understanding how to draw it the right way makes a huge difference. Okay? All right. Our angle B down here, not an obtuse angle this time, right? So now we have to do some work to decide. These are like our Twizzler problems. There could be 0, 1, or 2 triangles. This is the hard one. Okay. All right. We need to think about the height of our triangle. This is not a part of our triangle, like this isn't one of the sides, but do you guys understand how that is the height of that triangle? Okay. Any ideas how I might find that? Think back to SOHCAHTOA stuff. Not tangent, but one of them. Sine, yes. Could I do sine of 43.1 equals h over 248.6? Let's shoot. All right, and then how would I solve for h? Yep, so 248.6 times sine of 43.1. Getting like 169.9? Okay. So, what that means, when we look at the Twizzler here, or the rope swing on this side, and compare it to the height of the triangle, which one's bigger? The Twizzler or the rope, right? That's the bigger piece. That means this has 2 triangles possible. Think about your Twizzler activity. This is the third case. Remember where we swung it here and moved it over here? That's what is happening in this angle side-side problem. So that means you get to solve the whole triangle twice. Okay? You look at So this is like our rope or our twistle, right? Compare that to the height. If this is bigger than the height, swing it and touch it twice. Remember, it's like the long Twizzler piece, okay? If this had been really short, okay, like say this had only been 100, and this is still, you know, almost 170, it's like the little tiny Twizzler that won't touch the other side. Okay?
Do you have to check the height every time?
If it's angle side. So only problems that are a pain in your angle side do you actually have to do this for, okay?
So, is there a reason why we didn't do it on the last one?
It had an obtuse angle. It's different if you get to start with an obtuse angle.
Still, you should check if it's acute.
Mm-hmm.
Or if
Jonathan? Yes. Yep. And honestly, you won't see tons of those. You're either going to see 2 triangles or no triangle most of the time. All right, so we don't have to think about the height anymore. So I'm going to just get that out of my triangle, okay? I don't need that anymore. I'm going to start by solving this as if it were just a normal law of sines problem like we did on the last one. So I would start with sine of 43.1 over 186.2. And what would you set that equal to? Sine of c over, perfect, over 248.6. Okay, so you multiply by 248.6. And you're going to get a decimal when you do this. What do you do with that decimal?
Store it.
You don't have to store this just yet. How do I find the angle? What do you have to use on your calculator? Inverse sine. So remember, this is where you're going to do inverse sine of that answer that you get. And let's round everything to the nearest tenth on this problem. I don't know why we're changing, but let's just do that since your other angle was given to you then. So what are you getting for angle C?
65.
Yes, 65.8 degrees. All right, you should store that now, okay? So that's 65.81884422. Store, and I would store it as C. I want to stop there for a second and make sure everyone is with me. Ooh, hey guys, I gotta go grab my power cord. So. Hold on.
That took me a little bit.
Okay, so now you slide.
Oh wait, I multiplied it.
You guys are good now?
No, it's just a wait.
Okay. Anybody not here? Okay.
It's not working.
Oh, I was just kind of ready.
What do you mean? You do inverse sine if you're solving for an angle. If you're solving for a side, you don't have to do inverse. Okay. All right, so are we to the 65.8?
Store that as C.
Yep, store it as C. Okay, how are we going to find angle A then? Yep, so 180 minus 43.1 minus C, okay? Not the rounded C, but C that you stored, okay? Are you getting 71.1 as your rounded answer? And what do you think I should do with that answer? Store it as A, okay. And now how am I going to find little a down there? Or do I need to wait a sec? Yeah, back to your law of signs here. So we would do sine of 43.1 over 186.2 equals sine of your stored value for A over little a. Cross multiply, and again, if you're getting to the point where you don't need to show this work, I'm completely fine with that. So Felipe, like this is one you're not going to need inverse sine to get your actual answer because it's just A equals this. It's a rather large number. You're getting 257.8. Okay. So we're halfway there, guys. We have another triangle to find, okay? But I want to make sure everybody's good with this one.
Wait, so we have to do the exact same things we just did, right?
Not quite. There's a little less work. Again, this is by far the hardest part of this unit, is the ambiguous case here when there's two triangles that you have to solve for. I'm going to come down here and redraw this triangle just because I need to write all over it. Okay, does anybody have issues with the first triangle, or are we okay with it? Okay, so what happens to create your second triangle? This side over here, it was our Twizzler or our rope. What it's doing, it swings over until it intersects the triangle again. Remember how your Twizzlers made two triangles? Okay, that's what's happening there. So this new sort of obtuse looking triangle, that's the one you're going to solve for. B is still there, and it is still 43.1. This is now C. This is still 248.6. Here's your A, 186.2. So those three pieces of information you're given, the angle, side, side, those values cannot change, okay? You can move the one side around, but the numbers themselves are never going to change. Okay. Back to geometry, which I know you guys love. Do you remember anything about isosceles triangles? Okay, if the sides are the same, the base angles are the same, right? Yeah. Okay, so think about in my picture here. This is the same Twizzler over here, right? So these two sides are the same. What does that mean about these two angles? Those are the same. What about this angle and the one right next to it? What are those two angles? 180. 180. Okay. We have our C still stored, right? Yeah. So all you have to do is 180 minus C, and that gives you new C in your second triangle. So like 114.2.
We do 180 minus C.
Yep.
You couldn't do 180 minus 43.1 then. So that would work.
No, because it's not this angle that it's congruent. So, like, let's look at this picture. So, like, 43.1 is over here.
Oh.
Okay, I know, it got too tight there. These two are the same. Like, this is C. Subtract from 180, and that gives you this one right here. Okay? All right, are we okay with that? Let's store that. This is our new C. So all you have to do is push store alpha C, and you've just replaced it with your new C. How are you going to find angle A now? Yep, 180 minus the 43.1 minus C. And what should we store that as? Yes. So the only thing we have left to find is little a. We just go back to law of sines for that. So sine of 43.1 over 186.2 equals sine of your stored a over little a. And you should be getting 105.2. It's a lengthy process, I know, to get all the way through to that second triangle. No part of it is exceptionally hard. It's just making it all the way through all of those steps, okay? We will do lots of practice with these. Anybody questions on that one, though? So your answers, you have like two different sets. You've got C, A, and A from the first triangle, and C, A, and A from the second triangle. Okay? All right. Yes?
Could there be a case where where that angle is the same as that little large one? Like this is small, you use two triangles, what was the same?
Like that these and these are the same? The only way that would happen is if it's 90 degrees, and that's
No,
when the
like that
Twizzler.
number that we got, 169.9, the height.
Yes, if it equals the height,
Yeah.
then you have one right triangle. Remember when the Twizzler fit perfectly, the second case fit perfect? That's that case. Yep. See if a few people still writing before we try again. You good? No, I just don't want to go. Are we okay? All right. Okay. I think this is 3. All right, so same idea. I want you to set up your triangle to make sure we practice our rainbow drawing, okay? I'll give you a second here. Put things in the right spot. All right, guys, so what goes where? What goes in the bottom left? Okay, so C is down there, 42. How long is my tree? 122. And how long is my rope? And so then my other angles, where do the A and the B go? A goes up top. Good. B is down here. Okay, so you guys see the setup. Clearly angle side side, not an obtuse angle. So the first thing that should come to your mind is, okay, I'm going to check the height of that triangle. So sine of 42 equals h over 122. Tell me what you get for your height. 81.6. $122 times sine of 42. Past that? There's nothing past that. All right, so my Twizzler over here is 70. The height is almost 82. Is my Twizzler longer or shorter than the height? Shorter. 70 is smaller than 82, right? So this is the little short Twizzler. So is it actually going to connect to this other side of the triangle? No. So what does that mean?
We're done.
Yeah, it means no triangle and you're done, okay? Those are the best. No, yeah, well, it's just a whole test of those, right? Okay, much happier? Okay. Okay, we won't do another one.
What?
I know. That's not for you. Okay. All right, guys, so homework. In your packet is 5.2, day 2. Remember, so it's only angle side problems that require you to check the height. So if you look in your packet, like look at question 1. You have 45 degrees, you have 95 degrees, and you have the side of 5. Is that an ASS problem?
No.
No. So should you be doing all this extra work? No. Just do law of sines and solve. This worksheet does switch to Greek letters, so I just want to make sure you know that is the same as capital A. That is B. That is C. Okay, so you don't get scared on your homework. I would jot that down somewhere. All right. You guys do have a quiz next class on 5.2. We will obviously do some more practice before that quiz. You are learning law of cosines next time too, so got a lot to squeeze in next time. Yeah.
I don't know when the chances are.
ASS.
So every time you're in an ASS question.
Yes. Unless it's an obtuse angle, because then it can't be 2 triangles, but yep.
The angle of these is over 90.
Not necessarily. It just means there couldn't, like, this can't happen. Because think about this situation where the side can swing around. If it starts with an obtuse angle, can that side swing? Do you know what I mean? Like, there's nowhere for it to swing to. So if your given angle down here is obtuse, you don't have to find the height. Okay? So guys, you've got 10 minutes left. I would start And I'm putting stickers on your quizzes. I need to get them back to you.
There is a-
Yes. Just do lob signs like you were doing on your homework for today. Super easy. It's not until I think you get to like question 10 maybe, or 9. Yeah. Yeah, so there's not that many on this. Yeah. Are you what? I'm sorry. Of course, yes. Sure. Yeah. Yeah. There you go, Sonny.
Thank you.
Yep.